Hello, folks. It's George Leoniak, and welcome to New Geometry. I'm excited today to share a video around the sacred square roots. So the sacred roots. And my first introduction to looking at the square roots in a sacred geometric way would be through the work of Robert Lawler in his book, Sacred Geometry. His first three workbooks in this are directly related to the square root of 2, 3, and 5. And I did get this book 30 years ago, and at the time was nowhere near able to comprehend much of the geometric language that was in here. But over time, slowly understanding more and more, we're going to not really approach it from a geometric structure point of view, which I often do in many of my other videos, is talk about the polyhedra, but just a brief introduction to the square roots in the cube, for instance. Square root of 2, if you just take a square face and draw one diagonal across that, if both these edge lengths are 1 and 1, well, that would be root 2. And if we turn the cube into kind of vertical orientation here from opposing vertices through the center from vertice to vertice, would be the square root of 3. Now, today's video, I have a presentation set up. It's going to be primarily focused on how the circles interact. And this is really where the proportions show up and the ratios will be revealed. And there will be a lot of golden ratio discussion of how they're hidden within these relationships among the sacred roots. So let me hop over to the presentation, and then we will get rolling with that. Okay, so a few of these posts I was posting over at Facebook and New Geometers Facebook group, so go check that out. And just as another heads up, next weekend, week after the airing of this video, the end of August there, I'll be doing a New Geometers meetup, which will do some of the drawings that are in this video here. So check out the New Geometers meetup. It's over at New Geometers courses. Link will be below. So this one here is one of the first. I started playing with a lot of no line constructions, and I began to be curious, well, can I produce the sacred roots 2, 3, 4, 5, and so on, with just using a circle setup of the seed of life, the 6 circles around 1, and then finding the interconnection points to build these sacred roots out and expanding in this ever expansive puddle drop that of ripples going further and further out. Now I'm going to break this down and show you kind of the root mechanics of how this works, and this would be a fun drawing to do in the New Geometers meetup. But this one I was able to at least extend it out from 1 to 16. So square root of 2, now remember, these square root values, many of them are irrational numbers. So that'd be 1.414, square root of 3, 1.732. And then square root of 4, of course, would just be 2. So mixed within these square roots, for instance, like 9, of course, well, that would be 3. But a lot of the other ones have a never-ending sequence of digits after them. So this is really amazing that these radii of each of these are picked up with this circle construction. Now, when I first posted this, there was a little conversation about, well, how far out will this go? Clay Taylor, amazing geometer, has done some very great work with the golden ratio and many discoveries. He said, hey, well, let's take a look at it. I think I mentioned something about a circle limit maybe approaching as we continue to expand this out. But if we continue to zoom into something like this, you'll see that it's always adding little increments as you go along further and further. Between each of these blue circles, there's 2 additional circles that are added to the previous grouping, and it will just continue to expand for kind of infinitely. So this I went from square, from 1, the unit 1 circle in the middle, adding square root of 2, 3, 4, 5, 6, 7, all the way out to 100 here. And at that point, it's just doesn't make the sense to go any further. But there is remember, this is all based on the circle construction, and this light gray band that you see around here is actually two vesicas that continue to add to the creation of the root below those two circles. And I'll describe what that means in some of the circle construction demonstrations here. So let's just take a look at the inner, towards the center of the circle with the unit 1, and just what's happening with how these are being picked up, how the additional colored circles here are getting generated by the interactions of the circle of, let's say, the red circle here, root 2, is going to interact with these square root of 3 circles, and that will then be the place where you're going to be able to draw a root 2 where those intersect. And then if we continue up, we get an intersection point here. That's another place that will send this circle up to give us the next circle up, which would be 2. And then we've got another intersection point here, which would then therefore give us this circle here, which would go ahead and give us the root 5 circle up above. And you continue to be able to pick up the next circles. And this little line is pretty much will just continue on straight up through the whole diagram, that 1 inch. If this is 1 inch between the two petal tips, that just continues up, and that little series of dots will go all the way to the top forever, and being the place where you continue to grab the next circle that is larger. So that's just kind of taking a look at it for square root of 2 through 5. I would suggest that this is definitely a hands-on activity, and we will do something like this in the meetup if you can't just look at this and be able to decipher how I got there. Like I said, there doesn't need to be any lines done in the circle construction. I can just easily show how to do this with just compass alone. Now, after posting, some of this material over at New Geometers, Hunter Hughes, who's often posting quite a lot there and doing some amazing work, always digging into the new geometry and into geometry, sacred geometry in his projects. He sent me this triangle the morning after that post, and he said, hey, I was just playing around with some triangles and looking at some proportions. And what he did was he created a unit 1 base here and used square root of 2 on each of the sides. So an isosceles triangle, 1 and root 2. And he just sent a root 3, the next root in line, over and hit this base, right, of the triangle and extended out. So past root 2 was the golden division point where we'd have 1 and 0.618, 1 divided by pi. So he was pretty excited. He sent me this triangle early in the morning, one morning. And literally most of the images you'll see here just came in a flurry of activity within about a half an hour, because I was like, wow, let me check that out in the diagram that I had posted in a more simplistic version just right now, showing the relationship between the root 2 circle and the root 3 circle here, the blue one. And if I do the same diagram that Hunter did, in fact, his little triangle here is over top of the one that I have there. So I'll just pop that back into place. But there we go. If I extend the root 3 line down, it will hit the circle and the root 2 circle, and that diagram will work. So essentially, this is the circle template that, probably other ones we can use, but a relatively easy one to do to pick up this golden ratio division at the base on either side, 1 and 1 divided by phi and 1 divided by phi on either side. So of course, since I had that huge drawing out to 100, I was like, well, will this proportion continue? Will the golden ratio continue to expand, like in the relationships between these circles? One little thing I want to point out here is the circle that creates the root 2 circle here, okay? The one that's in the middle here, this colored one. That one is created by two √3 circles. See, one circle and one circle. Those two circles, this one out here, is the same size as the blue one in the middle. So when we take that circle and put it, the √3 circle, and put it over here at the 1 inch mark on either side of those pedal tips, make that circle, those two vesicas will give you √2. Okay, now that's the process I was describing in the previous image of how that kind of works. And we're going to kind of discuss that a little bit further. But let's just go along our golden ratio expansion mystery right now and at least go out to see if that holds, well, at least up to √6. Okay, so here's the 2, √2, √3, this 4, √4, which is 2. √5, all the way out to √6. If I continue to extend the lines between any two successive circles, so √2 and √3, which we saw, but let's see if it works for √3 and square root of 4. Remember, that is just 2. So square root of 3, square root of 4. Well, once again, that line from the previous root to the new root above it will continue to divide the line from 1 to 5, 1 to 1 divided by 5, 1 to 0.618. And of course, I wanted to see if it would do it for the whole big diagram that I showed you at the beginning. So I was like, all right, let's extend the line all the way up. And I've got my 1 continuing all the way from the base unit 1, following through all those square roots to 100. And if I extend that line out, we're going to pick up, and this is kind of down here, I've got a close-up of this in a second. Well, we pick up a few more golden ratio divisions as we go along there as well. These lines kind of extend down in there. So that's an infinite pattern, and it will continue to produce golden ratio when we use unit 1 through any successive 2 square root radii. The intersection points, when we extend that 1 inch out, will always produce the golden ratio between those two. So just taking a closer look at that, and I think this is what I said probably a little more better. When the unit 1 segment remains constant on the vertical axis, which are these two lines, the next square root circumference, so if we've got square root of 98 here, and then we pop up to the square root of 99 here, we'll divide the extended line segment, which is this horizontal line going across, into the golden proportion. Okay, so there's 1, there's square root, the square root of 9 radii, so this circle's arcing through, and then this little segment, of course, will be 1 divided by 5, 0.618. And the next square root circumference, after the divided, after that divided, I don't know what I wrote there, after the previous one, basically, this little section here, will also pick up the 1 divided by phi squared. Okay, so that's the next little golden ratio proportion past that. Okay, but that's at the square root of 100. Okay, so that will also happen again if we did the 1 at square root of 99 and then kick that line over to square root of 100. Well, you can see that those are also going to maintain golden proportion through it. So pretty cool to see that. It was a neat kind of discovery to see just how far that will go and how these two successive roots and in the third mixed in there. And if we lower this line down, we pick up a few more, as I showed here, that will continue to show more golden ratio division. So here's just these 3. Then we get kind of going from the other direction, 1 divided by phi squared, 1, whatever. We got a lot of things going on here in terms of golden sections. Okay, so let's just bring that back to like a more manageable scale. I mean, I'm not going to be doing drawings way at square root of 100. probably anytime soon. I think that was probably maybe the only one I'll do. But this one here is something that I work with all the time. Draw the seed of life. Let's go ahead and put square root of 3. And I'm really enjoying putting the square root of 2. We're going to focus on this square root of 2 circle kind of in the next portion of this video. So here we are. We're just laying our line out. And of course, we've got the 3 segments of division that I just showed you that were way up there. One divided by phi and 1 divided by phi squared. And that's happening at the 1-inch radius circle, the 2-inch square root of 2 radii circle, and the square root of 3 radius circle. All if we just draw a line, basically, like we're regularly going to draw just a star, right? The hexagram star. But this leads to a cool discovery that was literally discovered within that little half-hour back and forth that Hunter had on that morning. I said to him, even in there, I said, hey, what do you think this may lead to? And this is what it leads to, of course, a dodecahedron. Another new discovery that if we do that line and just simply draw the hexagram, Star of David, hexagram star, and if we do that, what will happen as it interacts with that root 2 circle, which I haven't colored this time, but it's the same one that is this red one over here in this image, it will give us John Melchizedek's missing line problem. Well, the lines have been found again easily within this diagram. You don't even need to draw these golden ratio circles here because the line is divided by the circle itself. And we don't need the additional circles. And of course, we can draw in the rest of the dodecahedron angles, and these are 164.5, which they'll always be on any orthographic drawing of a dodecahedron that maintains the golden ratio. So another nifty way to produce a dodecahedron from that simple construction. This is just loaded. I did the drawing in GeoGebra, and it was just loaded with all the golden proportion numbers and the sacred roots and proportions. I think, fortunately, Robert Lawler has passed on as of early this year. But I think he would have really loved to see this because one of his workbooks in here, of course, are the, and of course, he may have known a lot of this information, but it really matters if you start your drawing of this dodecahedron with the 1-inch segment, and then, of course, square root of 3 shows up. So I think this would really be a great addition to the sacred geometry philosophy and practice because all the Platonic solid golden proportion relationships are showing up in this drawing. So we've got 1.618 golden ratio. Root 2 is part of this. Root 5 is even in the line segment here. This letter under here is J8. If you look at these numbers, I unfortunately covered up in the picture here. That's the 1 divided by phi square number, the 0.38. This is a golden proportion, 1.07. That's a golden proportion number that is, if you divide square root of 3 by phi, you get this. So we got a lot of basically sacred geometry described in a dodecahedron. First most important square roots, first 3, and the unit 1, and divisions of the golden ratio in there. Pretty awesome. So let's go ahead and take just a quick look at some other golden constructions that blew my mind. The one on the left here I've talked about in other videos, but I have another new one that I believe is a new golden ratio construction, and also how to draw a square and to get into square view without using any lines at all. This is what this little diagram is. You don't need any lines to draw it. And of course, all you have to do is draw the 45 degree angle, the diagonal across the face. Of course, the radii here from A to Q is square root of 2, and then we get golden proportions. So phi divided by, or square root of 2 divided by phi is 0.87. And if we go ahead and divide that segment by phi again, we'll get 0.54, which is this little remainder. That's just built into the sacred geometry. It's just the fact that it is golden proportion, can be produced easily in a square drawing, square view drawing. And the hexagon, which I talked about this one, I've seen other variations of people who've done this without showing you the whole circle template like this, just pieces of it. It's essentially a same drawing. What I love about these drawings is that the vesicas themselves are the interaction point where the golden proportion is created. So you have to look for the relationship between the circle and line on that one, rather than just two lines crisscrossing to make a divine cut. It's the arc of the circle that interacts with that line that is providing the golden proportion. In some of these drawings, they don't need any interaction with lines. The circles themselves, just where they intersect, will provide the golden ratio. So golden ratio is hidden in a lot more drawings, and there's a lot more interesting constructions to find out there when we look between the lines. So let's go ahead and take a look at the next drawing, because I was like, this is great. I have a square that easily produces the golden ratio and a hexagon that produces it. And of course, we have a square root of 5. Remember, this is based on the root 2 circle and the root 3 circle. So of course, I want to see how a root 5 version of this can be produced. So let's go ahead and take a look at this construction, which I think is a new construction for drawing a pentagon, a perfect pentagon with 108-degree angles. And it has the nice thing about this drawing, which I drew in my Patreon group this past month. We go ahead and create a radius circle in the construction of square root of 5, which is 2.23. And then we use the central circle, which is 2 inches, and then we'll have a remainder of our segment. Another geometer, I'm forgetting his name, has come up with this kind of construction. This is a pretty common one. But the thing that's not common here is how to produce your pentagon in the root 5 circle. And I wanted to kind of have a trio of images here that both all show how we can get the square, hexagon, and pentagon, all containing golden proportions within the base of the drawing, within their specific root, okay? Because the root 2 is related to the face of the square here. The root 3 is very much about the flower of life hexagon layout. The root 5, of course, is very much related to golden proportion in phi, right? So it was kind of a little challenge for me to figure out how to get that last pentagon one. Now, one thing I'll say about each of these, as you see, the seed of life is the basic construction. I didn't draw it in on this one, but if I were to produce these images without using any line to get a vertical line to do this, then using the seed of life after this little study that I've been doing of entering into a drawing just with the compass, the seed of life appears to be the most foundational way to enter any drawing without using your straight edge to get square view, hexagon view, and pentagon view just based on using your compass. So seed of life, I believe, is the most, the starting point of sacred geometry. Entering into sacred geometry drawing is seed of life. So let's have some little Platonic fun here with some golden discoveries based on square view. So here's this intersection, and nicely, that's where the square of the dodecahedron, the cube of the dodecahedron, intersects. So if I just extend the line down to the outer edge of the cube, then all of a sudden, wham, I got the dodecahedron, just like that. Very simple dodecahedron. Now remember, I teach also how to show all the golden ratio circles to produce the same drawing. It's one of the bases of new geometry, is working with the golden circles. But any dodecahedron you draw is, if it's orthographically a biproportioned one that is full of golden ratio, it's going to have the golden circles that are just not obvious. They're invisible golden circles here. And similarly, the icosahedron, we just have to add in a few more setup lines that are off of those intersection at the golden point, and then we will get our icosahedron. So dodeca and icosahedron are nicely drawn there. Another one that I was super excited for, this is my big color image for this one, and the phi yantra, which I have a video on, discovery of that over 2 years ago, maybe 2 or 3 summers ago now, I'm not sure. But that was a huge expansion in my understanding of utilizing the golden ratio. The technique I just showed you easily draws this in a way that I've never seen before, making it an easily friendly, easy way to integrate this into the pattern language of sacred geometry through that √2 circle and getting all the 3 squares, 1, 2, 3, 4. Some of them are hidden in the way that I designed this, colored this. But 3 squares, basically starting from 1 out to the phi cubed, 1, phi squared, and phi cubed. And in fact, this drawing is exactly done to those dimensions. So phi yantra was nicely found in there. Check out the phi yantra video. You could see sort of how this kind of kicked off and got going with the golden expansion through learning square view relationships. So let's go ahead and take a look at this because I wanted to really work with that √2 radius circle. I had a lot of fun looking at the other 3 major orthographic perspectives. So it really provides a nice all-in-one technique. And whenever I come up with a new circle template, I often like to try and draw the dodecahedron because it's a little more challenging than the icosahedron usually. And I wanted to see if I could go to any of these 3 views just by adding that red circle. And yes, that is a possibility to do in all of them, adding in the additional circles to go to square view. And you don't even need these other circles to do the square view. Remember, these could all be basically the seed of life, but this is your 2-fold, 3-fold, and 5-fold, all from using the √2 radius circle. All right, so we have the next one here is the kind of flow that I've been in recently as working with this was to look at these roots of relationship. And so what this sequence describes kind of goes back to what I was talking about earlier, that the root circles that vesica of the root above it, if there's 2 of those, will produce the one below it. So let's just check this a little bit at a time because it's a really interesting relationship that starts here, okay? So we are going to start with the seed of life, and it's going to be a unit 1 circle to start, and then we draw the seed of life. Now, why do I have 0 creates 1? Well, we'll start with 0 as the dead center point of your drawing, and then of course we have the 1-inch radius. And then I have this here, √2 creates 1. Well, what does that mean? Well, what that means is that I'm using a √2 circle, which are the circles that are around the unit 1 circles. And when I do that, let's zoom in on this image just so you can see this up close. All right, so when I do that, what happens is those √2 circles interact, the vesica that they create, 2 √2 circles, just look at the horizontal line, they create this little almond right in the middle, and that vesica is right at the 1, the unit 1, which is really 2-inch diameter, but unit 1 radius. And these circles are √2. So that's why I'm saying √2 creates √1, although we already had √1 we already had 1 created. Just take a look at this one and I won't zoom in again. Next one. So this one says √3 creates √2. So we're going to take our √3, and √3 actually from this diagram beyond it, but these larger circles are √3, and we can pick them up in our drawing at this intersection point. And here's our almond in the middle, another vesica. And where those root 3, 2, and I am showing here are 6 circles, but all you really need is 2. That's what the prior drawings were showing. But I've put it into a 3-fold symmetry. And like I said, you don't need any lines for this. But if you go ahead around and use root 3, then root 2 is created, the radius of root 2 at this black circle. And that's basically what happens for all of these drawings that I'm about to show you. So root 4, which of course root 4 is 2, is created by, creates the root 3 circles. And each of these are like a circle template in and of itself to explore. So all of these circles that are the ones that are creating the root below it, the ones that are creating these vesicles, what they're doing is they're always starting at the circle radius of the central circle, the 1. They're always starting at unit 1 away from the center. So all those circles are always centered on the same spot. And when we do that, they keep producing the next root above it. So the root 5 will create the square root of 4, and root 6, these larger circles here, the vesicas of those, when they intersect, will produce a square root of 5 circle, and it goes on and on and on. Now, I won't keep saying which one creates which one, but you can see we got some nice templates showing up. And one thing I started to pay attention to was where the root 1, the unit 1 circle will start to reconnect with this expansive circle pattern that's happening, right? Because when that happens, then you get like the flower of life pattern. So at 6, at root 6, okay, we get the intersections at these farther out nodes here, where those original circles that we started with will go ahead and connect to this square root of 6 radii going around. So we're going to start to see some interaction like that. And because it's root 6, the next one in the sequence is going to follow a 3, 6, 9 progression. And those are always going to be on the right of this next 2 slides, okay? So here we go, we keep going. We've got, root 8 creates root 7, root 9 creates root 8, root 10 creates root 9. Here we are at root 9. So root 9 is the black circle, and root 9, of course, that is 3, and we can easily kind of count out from the middle 1, 2, 3 segments. So we know it's a 3-inch or 3-unit segment, and of course that's root 9. So, and we came from root 6, which started to integrate there as well. And then we keep going to this extension root. Root 11 creates 10, root 12 creates 11, root 13 creates root 12. And once again, we're back to a number that's going to add up. If we digitally compress 12 to 3, then all of a sudden we're back at another little jump in the flower of life expansion, and we have added another rosette of circles at root 12. And I just went out a little bit further to just see what's going to happen, just to make sure that at root 15, we will go ahead and get another intersection point. So root 15 is integrated in, so 5 and 1 add up to 6, and of course 8 and 1 add up to 9, so 3, 6, 9 continued expansion. Well, you say, well, I didn't really talk much about root 3. Well, that's the way back at the beginning, but at that point, it's kind of just the seed of life. It's already well integrated into it. You can see that those circles are already at those nodes. So we do have 3, root 6, root 3, root 6, root 9, root 12, and root 15 and root 18. Those are all the major intersection points of the original Unit 1 circles. And as you can see, the original seed of life is kind of being contained with larger and larger negative space at the center here. And it kind of populates when we hit these major node points. But these circles don't necessarily interact with these sections of intersections between the two numbers between 6 and 9, for instance, or between 15 and 18. Now, we want to take a look at this, and we're almost done with the presentation. So I wanted to check out, of course, how the golden ratio is going to integrate into the relationships of these roots, root 2 creating 1, root 3 creating root 2. You could see down at the bottom here. And these are all circle templates that I've come up with and figured out, and I use each of them in creative ways because I have a lot of different circle templates that work with the golden ratio, and these 5 are ones that I all figured out before this whole root progression type of thing, and some of them were, of course, figured out by other geometers before this, when I've looked and found that they have discovered some of these and used some circle techniques that don't quite use the full rosette of circles going around 6 around 1 to show these, but I like to do them as 6 around 1, or because it will allow for doing, drawing the Platonic solids easily, or building other polyhedra within a full radial symmetrical version. You don't always need to do that, but it's nice to see all the circles in their fullness in some of those drawings. So these are, I know this is small here, but these, clock arms that's going around here, they're at, 0, they're going to go around, they're meeting at the 30, 60, 90, 45 from this direction, and, back to 180 or 0. So they're meeting at these critical intersections of, I guess, another 30, 60, 90, 45, all numbers that add up to 9, no surprise. So just the really cool circle templates. Now, you're asking me probably, or thinking or wondering, well, hey, what about all these other ones that you continue to expand out on, right? So it's really cool that these first 5 roots do that sort of interactions. But what's going on with golden proportions as these roots continue, root 15, root 14? Well, I did show you early on, there is that extended line, right, way back to this portion of the presentation, where they extend the lines out in the golden proportion. That will maintain. But as I hunted around a little bit more beyond 1, 3, 2, 3, 4, and 5, the square roots of those, I didn't easily find other interactions or intersections where I can just send one of those lines out and those vesicas would divide into golden proportions or something like that. Definitely a fun little research experiment if someone can find some more. But it wasn't an obvious relationship. And that's probably why, one of the reasons why square root of 2, 3, and 5 are, back to Lawler's book, the ones that are most frequently used by a sacred geometer. And here they are all showing how to produce golden ratio. And this one includes root 6 within this, if we base it on my previous drawing. And here's the kind of unity drawing of all of them together. Now, one other thing that I want to try and describe, and I hope I do a good job of this, is the last post, or not post, this is a post I did, but this is the last slide in this presentation, is something that I did post over on Facebook, and probably not many people would understand what the math is behind this. The most, regular viewers who are not into serious, geometric progressions and crunching numbers like this. But I'll try to describe this the best way that I can here. And I have a little example with the numbers down here. So what's going on is that there are golden ratio progression in relationships happening for each of the square roots below this. So we have a 1-inch square, right? So this is the unit 1 square. And the next square in this sequence would have an edge length of root 2. The next one would be root 3. And anytime you draw this diagonal through all those roots, so I'm going from 1 to 9 here, and if I were to swing that diagonal all the way down to the horizontal, to the vertical line here, well, that place where the last square was where the edge of the square is, when I extend that line all the way down, this length, this segment, is going to be, let's just call this big thing 1. Well, the remainder of that will be 5. So what I'm doing is swinging all these down and seeing where they intersect on the upper half of my drawing here, right? So I wanted to see if there was a relationship, because I know when I do that with 1 and I swing that down, I'll always come up with root 5. It's just, that's how root 5, one of the constructions is. So I wanted to then see if I did that for root 2 and I swung it down, will it intersect with a root above it, right? That's somewhere floating out here. And yes, root 2 will connect to root 10. And root 3, when I swing it up to the top, will hit root 15. And root 4, when I swing it up, will go to root 20. Now, one way you could kind of do a simple calculation to figure out which square root you're dealing with. So let's say we go to square root of 8. Well, just take 8 and multiply it by 5, and it will be 40, right? And then you just put square root in front of the 40. So any number times 5 is going to be the higher root, and then you just have to turn those numbers into square roots, okay? And that progression will continue on. But how to actually calculate the value for phi once you've done all that? Well, let's just look at the bottom example here. We've got square root of 9. Now, that's the radius that we're dealing with. So we have to multiply that by 2, because it has to actually be the length of the square. And then we're going to, let's say we took 9 and times it by 5. So that's 45. So we'll take square root of 45. And then that will be the radius from here. But we've got to deduct the square root of 9. So we take away square root of 9 from square root of 45. And that's the calculation for any of these, okay? So root 9 times 2, or the value, divided by square root of 45, or by minus square root of 9. So 2 times 3, because square root of 9, square root of 45 minus 3, which is also square root of 9. So then we come up with 370. 6 divided by 3.70. That equals 1.618. And that's the infinite golden square root progression between the lower roots to an upper root that is always not 5 times the square root, but 5 times the whole number value there. So 9, 7, 5. All right, well, I just wanted to describe that because it may have been a complicated slide, but it's something that came out from here. You may or may not be into that, but what I do hope that you take away from this, if you're into the artistic expression of this, is to gather kind of an appreciation for when you're just popping circles down on your page and they're interacting in all these interesting patterns that I'm showing here, which do lend themselves to beautiful mandala creations. Know that the sacred roots are popping up on your page without maybe you knowing the relationships there. But when you do start to explore sacred geometry and know those relationships, and they become a new, the new feeling with them arises in you, then you'll start to, be able to understand a book like Robert Lawler and Sacred Geometry and understand why it's called sacred geometry, as in sacred, because these are the proportions that will always show up. And as I'm showing here, these proportions and these vesicas of circles and interacting from the first slide here will produce these ratios, these sacred roots at an infinite scale. And they're eternal roots. And these diagrams that I'm showing here and the golden proportion in it are eternal diagrams that are related to the forms that we love, the starting Platonic solids, and other relationships within the world of sacred geometry. So understanding these proportions and how they integrate with the drawings does not detract from you from doing amazing, beautiful artistic creations. All it does is enhances your deep appreciation. At least this is what it's done for me. Enhances my deep appreciation of just how magical and beautiful the mathematics, the science, the artistic expression of it, imbuing this new feeling within me. Like I said in one of these posts, it never gets old. It always feels new. And as I expand my consciousness to greater and greater depths of understanding the beauty of this creation and the sacred mathematics and geometry that are behind it. So I hope you enjoyed this presentation. Like I said, one more time, go ahead and check out the New Geometers meetup. I'm looking forward to sharing one of these drawings, and take any questions about anything that I displayed here in the video. And check out New Geometers Facebook group, and also have some cool apprenticeships coming up and a master class based on some of the previous videos that I've done of the core 4 forms. So lots of new geometry, NEW as well to share. So go ahead and check out New Geometry courses, check out New Geometers Facebook, and thanks for joining me here, and subscribe to this channel if you like this content. I'll be back with more soon. Much love and peace. Have a great day. See ya.